So hello everyone, and welcome to today's session of PractiTest webinar series, where we host Robert or Rob Sabourin. I hope it's okay. We call you Rob. In a session about SEBTE or CEBTA, I will let him to explain, and a simple, effective, experience-based test examination. We are very, very honored to have Robert with us today because he brings tremendous experience in testing and the testing world. He has more than 39 years of experience in management, leading teams of software development, and he has trained and mentored and coached thousands of professionals in our profession. So it's a great, great honor to have him with us. He frequently speaks at conferences if you had a chance. If not, you might will be in the near future, perhaps in the virtual world and hopefully soon in real life. He spoke in SQA. He's doing testing and management international. He's authored the I Am Bug, a popular software testing children's book. So if your kids don't know him yet, maybe Rob will mention something about it after his session. And he's a professor. He's an adjunct professor for software engineering at McGill University. And this is a huge honor for us to have him with us in the respectful list of other professionals speaking, but he's for sure one of the most experienced and respectful ones that we had the pleasure of hosting. So thank you so much, Rob, for being with us today. It is a great honor. Before I lend you the permission to speak and the joyful for us, I just gonna mention that very, very soon our results for the state of testing survey will be published. We're just analyzing them today. Another activity by PractiTest, okay? So in case you're not familiar, you can go and find the results of the 2020 state of testing reports and the previous years, but we are currently working on 2021 and hopefully they will be out very, very soon. Obviously we will announce that. And now I'm bringing the torch to Robert to present.
Torch.
Sorry,
okay.
I lost the perfect word for that. So Robert, it goes to you. Thank you.
Should I share my screen now?
If you can, yes.
Okay, please. Just bear with me. The technology is here, and let me know. Can you see my shared screen now?
Yes, wonderful.
I'll begin then. Thank you. Thank you so much for the beautiful introduction. And whenever someone makes an introduction and I start feeling older and older, I know it's a good one. I know it's a good one. Wow. You say 39 years of experience, and I try to think back, and I said, I wrote my first code in 1972, and I learned about testing the first day I wrote my first code. So it's been part of my life, my whole life. My dad was involved in testing. He did automated testing of telecommunications switches in the 1940s. So it's been a huge part of my life. And my first commercial release was actually June the 4th, 1982. So when I say 39 years experience, that's sort of like starting after my first commercial release. Anyhow, it's an honor to be talking to you. And today, in the short time that we have, I want to talk to you about a simple, effective, experience-based test estimation approach that I use, that I have used, and that I continue to use on many, many, many projects. So it's something that has helped me a lot. And I'm not going to suggest that it's a generalized solution that will apply to everybody. As the expression goes, your mileage will vary. You may be able to take all or part of this technique and apply it to your problem space. But the practical element of this is it's simple, it's real, and I've got way over 10 years of evidence of it being very, very effective, at least in the projects that I've had it worked on. And they've included domains, including financial services, insurance software, banking software, and methodologies, including Agile and traditional methods. So this is the technique that I've used independent of the life cycle model, and it's been very helpful. So I hope to share it with you. In order to discuss estimation, there's a little bit of background that I want to share. So I put together a little mind map. and then I'll dive in and show you an example method. And if you're interested in copies of the examples I'm sharing, articles about this information, little case studies I can share, I will make available to anybody who's participating in this webinar afterwards a link to a Dropbox with all the examples, case studies, spreadsheets, and all that type of stuff. And I'll do that through the hosts of the webinar. So please, please, please let us know afterwards if you want a copy of the stuff, and we'll get you a link to examples, case studies, and especially people love the spreadsheets. So happy to share that type of stuff. All right. When the world of software changed, there was a change. It was February 2001, and 17 software development professionals went on a ski trip in Utah. And this ski trip was an excuse for a peer conference to discuss lightweight development methods. This became the foundation of modern agile development. That's the fulcrum. That's the point in history. Now, the motivation for that meeting is interesting, because prior to that, for the couple of years prior to that, major market research organizations, including in the United States, the Standish Group and the Gartner Group, published scathing reports about the state of the software industry. And in these reports, they said that especially numbers from 72 to 85% of projects were failing. Software projects were failing. There was a crisis, and they blamed it on estimation. They blamed it on estimation and poor requirements, and this motivated people. The estimation problem motivated people to share methodologies that could give you more predictable software projects, more deliverable, useful, valuable software projects without all this crazy uncertainty surrounding bad estimation. And that led to agile engineering. So it's interesting that the whole major shift to agile started with bad estimation. So if we were good at estimation, we probably wouldn't have agile development today. It's an irony. It's a beautiful irony. But this is something that I want to point out to people. It's not a new thing that it's hard to estimate in software engineering. It's not a new thing that it's hard to estimate in software testing. There's a whole lot of uncertainty. There's a whole lot of almost emotional chaos in these projects. How could I estimate how long it takes to test things? It depends how many bugs are. It depends how many people are on the project. It depends how much code it is. It depends on what environment. It depends on the users. It depends on the network. It depends blah, blah, blah forever. There's so many factors that influence estimates that it becomes really challenging to pin it down. So I take a step back and I say, well, I in my career have actually been pretty good at estimation. So I want to share some insights into that. And one of the things, first of all, I start with is, for the purposes of this discussion, I want to anchor what an estimate is. So briefly, if you go to the dictionary definition, an estimate is supposed to be a tentative evaluation or a rough calculation. It is not a commitment. It's a tentative evaluation or rough calculation. And I believe that. And when I present estimates to people, by the way, I go out of my way to emphasize that it's a tentative evaluation and a rough calculation. And as I learn more, I will adapt and evolve my estimate. So for me, an estimate is you start with something and then you adapt and evolve it. And as you learn more and more and more, it gets better and better and better. So it's preliminary. Very often an estimate is used to decide, should we do the project or not? So it's costing. It's used to help cost things out, to make sure it doesn't make business sense to do this project. And it's also something that is interesting, because an estimate is actually a judgment. An estimate is your personal opinion. It's really interesting when you look at this and you start realizing this notion of, is it subjective or objective? Well, actually, it's got a lot of subjective elements to it. Now, what you want to do is you want to present it in a meaningful way and provide an information and advocate it so that people can make good decisions with it. So is it important that it's deadly accurate? Maybe, maybe not, but it's probably important that people can use the information to make a decision. And sometimes the decision is, well, we should learn more so we can get a better estimate. Or sometimes the decision is, that's ridiculous, we're not going to do this project at all. Or sometimes the decision is, well, we've got to change the scope of it so that it fits into our models. So just to say that we got to start with the notion of what is an estimate. And I break the line, an estimate for me is not a commitment, but based on what I know, based on the information at hand, based on whatever constraints are on me, and based on maybe assumptions about things I don't know, this is my opinion of the amount of effort or the amount of time or the amount of resources that we're going to need to consume to achieve our goals. The goals vary too, right? So not all projects have the same goals. Moving along, just not to spend the time, we're not in a dictionary class here, but you got to start with something. It's possible to estimate with very little information. In fact, it's possible to estimate with no information. This is a cool thing. What we call zero information models for estimation. So imagine that someone comes to you and says, hey, Rob, how much effort is it going to take, or how long is it going to take to estimate this project? And you listen to them and they say, it's Project FISBIN. And they said, what? I never heard of Project FISBIN. What's Project FISBIN? I don't know what it is. I don't know. How can you ask me to estimate a project I've never heard of? Step back and wait a second. Don't get mad at them. Don't get frustrated. Don't get into an argument about them. Listen carefully. That stakeholder doesn't know. That stakeholder is naive. It's not that they're foolish. It's that they're ignorant, and they need knowledge. And that request is a bond of trust. They trust you. They're asking you something that they don't know is foolish, and they trust you to help them, to help guide them. And I love when someone asks me a question like that. I said, wow, you trust me about something that you don't even know about, or I don't even know about, or I've never heard of? And I love to start with that there's something of trust in there. And when someone asks me to estimate something I've never heard of, I basically try to turn it into a question of well, first of all, why are you asking? And very often it's because there's a new project on the horizon that they don't know much about, but they want to get a sense of before they start. So what I do is I ask them, okay, I don't know what that project is, but let's talk. Has there been something done in the past, something similar in the past? And you look at projects, and I look at projects in the past, and I say, okay, can we identify a similar past project that we did in the last few months or the last year, something in the recent past? And then once I've got that, I'll look at that, and I'll look at two dimensions. And this is my habit. You could look at more dimensions, but two is nice and practical, and also non-technical stakeholders can grasp it. And usually the dimensions are a dimension of size and complexity. And for a non-technical stakeholder, size has to do with usually the number of controls, the number of options, the number of things you can do. So that's a size notion. And complexity has to do with really the type of the algorithmic complexity, the type of research elements, the type of business rules behind it. So are they complex, simple, or typical? And you have past projects that they can say, aha, FISBIN is similar to the project called Romulan that we did 8 months ago. Oh, okay. If it's similar to Romulan, then you can check your collection of past data that you've collected. If you have this, if you follow my methods, you have a little bit of data. And you'll say, well, when we did Romulan, that project took us 8 person-months to test. In 3 months elapsed. And when we shipped the product, we had 15 bugs we had to fix within the first month. So probably we should have tested it a bit more than we did. Now you've given your stakeholder not an estimate on what it takes to do FISBIN, but a reality check on what happened the last time you did a project like FISBIN. And that very often, with zero information on the project, has really helped your stakeholders a lot. So you can actually estimate with almost no knowledge at all about the project if you sort of realize you're in a position of trust, and when you're asked for the estimate, you're asked to help somehow the stakeholders. So there's a trust that's going on there. And I think that if you can help people make good decisions, you're going to build credibility, and that credibility will help you advocate quality, help you advocate whatever principles that are important values to you and your company and your stakeholders and your team. What do we estimate? Second thing here, what do we estimate? So time, for sure. When is it going to be done? Okay, so time is important. Usually I say relative to a start, when will it finish? All right, so that could be talking about a story in an Agile project, or it could be talking about a whole product development effort, but still time. People are very concerned about time. Some people to a fault, and even time, there's a why time. It's funny to note that sometimes time is actually the critical element. If you're in the fashion industry and you don't have the product out at the time that the season starts, you lose a season. So that's a quarter of your business revenue. So time is critical in the fashion industry, even though a lot of people think that's fluffy software. Well, yeah, but it's time critical. Medical software, time critical. There's financial software, time critical. There's release for tax software, time critical. So time might be one of the most important things to estimate. Effort is also, for me, what I usually estimate. I spend a lot of my career in product development. So we're estimating effort, how many person hours does it take to do something? So I'm a big effort estimation person. But you can also estimate scope. And that's an important thing to note. You don't have to estimate effort and time. Sometimes effort and time are locked in and fixed, in which case you can estimate the scope of testing. And scope of testing is very important. It includes what you test. So is what risks are we going to learn about what we're testing? That's the scope, part of the scope. But the other part of the scope that people forget about is the depth of testing. So we can estimate the scope and depth of testing. And some features we can test shallow, and some we can test deep, and we can propose different scenarios to our stakeholders. So we're not estimating effort and time, we're estimating scope. And that discussion is very often a beautiful discussion to have. So, by the way, someone asked about the spreadsheets. Yes, I'll share spreadsheets. Yes, I will share a mind map and a PDF. The mind map I'm sharing is a simple free mind format, so I also include a PDF of it. So that's basically the thing. So many testers forget about the issue of, hey, if the time and the effort are fixed, let's estimate the scope. And don't just estimate one scope, provide your stakeholders with a few alternatives. Here, there's choice A, choice B, choice C. And if you do that, the discussion, I've noticed, almost always becomes, should we do A, B, or C? And then they start saying, well, part of A, part of B, and they come up with a synthesis that's D, which is a little bit of A, B, and C combined. But instead of squeezing you to try to say, no, you've got to do it sooner, 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 and you saying, no, it's going to take 3 months, 3 months, 3 months, they're saying, sorry, all we've got is 2 months, then, well, here's some alternatives of what we can do in 2 months and what risks we're going to take. So in 2 months, we don't test the performance. If we have a performance problem, we're going to have to recall the release. That's a risk the business might be willing to take to get the thing on the market in time. It's not, for me, my decision in testing to make, but it's my job to advocate a path, but to also provide the alternatives and make sure people are making a good business decision based on risk. So estimating scope, what's tested, and how deep. And every single test objective can be done at a different depth. Think of testing any feature. Can I test it shallow? Can I test it deep? Can I test it thoroughly? And you'll realize that that's a different thing, and you can estimate that. So why are we estimating? There's purposes for estimation all over the map, right? For me, key dates and figures, that's the business decision, go, no go on a product. And when I used to do that, by the way, I estimated the testing costs, someone else estimated the sales. And so it wasn't just, Rob, you squeeze Rob on testing. It's the sales. Hey, how much are we going to sell of this product? And it's not just me, it's other people that are trying to work together in other departments to build an estimate so that we can make a compelling business case for the product. So now your estimate is part of a team trying to figure out the best way to get a product to market so the company can make profit, you can get paid, you can live another day. Another way to estimate is budgetary. Sometimes you're estimating to know how many people you need in your team. How many square feet do we need? That's a budgetary estimate. How much capital is it going to take? Planning release milestones, that's the time ones. Sometimes you're a contractor and you're doing a competitive bid. And so the better your estimate, the more you can make a predictable bid. A fixed price contract, if you estimate badly, you're going to lose money. So this is basically the question of competitive bidding is really one of the places that you will learn a lot about estimation. If you ever had a chance to work in that space, it's really interesting. Coordinating with other people, you estimate to make sure that we're in sync. Sometimes I use estimation investment models. So rather than looking at a software project saying that it's going to take this much money or this much effort to estimate some things, sometimes people say, okay, here's how much money you have. How is it going to spread on your product? And so I take the money of the budget and I sort of spread it like, this is an analogy that works in Canada. I don't know if it works around the world, but you take peanut butter or hazelnut spread or something, and you spread it on a biscuit or a cracker. When you start, the cracker's all rough and striated. And when you spread the peanut butter on it, it gets smooth. And for me, this peanut butter is a metaphor for the budget. And I spread it across the cracker, which is the risks. And you'll notice the depth of the peanut butter. Some places very shallow, some places very deep, but from the outside, it's smooth. And for me, that's the peanut butter analogy to estimate. So given a fixed budget, estimate how we're going to cover the risks. So that's motivations for it, fixed budget stuff, very common for me. There's many different estimation approaches, many. I have studied and used many approaches, and I urge you to learn about as many as you can. It's a wonderful, interesting field full of almost science and mythology and magic. It's like reading Lord of the Rings to look at the trip to Mordor, carrying the golden ring. This is an estimation project. When are we going to get to Mordor? How are we going to do that? What route should we take? Are we all going to get there at the same time? There's so many different approaches, and all of them have value in context. So the factors that govern what is a really interesting approach relate to the business, technology, organization, and culture. And that's maybe that's another webinar someday on how those factors would vary things. But certainly there's a lot of different approaches. SWAG is a wild guess. WBS is a project management approach called work breakdown. Ratios is a method where you look at the development effort to estimate the testing effort as a ratio. Some companies prescribe that. Wideband Delphi is a team-based estimation approach that's really handy for software projects, especially with a lot of unknowns. Analytic models are things that were designed by studying a lot of past project data by people at places like Carnegie Mellon, things like function point analysis, test point analysis, all sorts of mathematics behind that. There's Monte Carlo methods, which involve randomizing, which I've used on a couple of projects and is very handy in the right project with the right data. That's random modeling. Agile teams since the early 2000s have been very, very much using story points for sizing at the requirement level. You're sizing stories, so you're not separating testing from development. You're sizing the whole thing, and they call it size. They use the term size as a sort of a measure of how much effort is going to be required. But it's an interesting methodology that really is effective for Agile teams who work off a backlog. There's T-shirt sizing, which is another similar Agile method where you basically try to figure out relative to standard sizes, is this big, small, or medium. And there's also models like I'm going to show you now, which is called the size complexity model. And so just think, there's so many different approaches. Look behind me on the shelves. I've got shelves for, basically 15 bookshelves down this way, all about software engineering, over half of them focused on software testing. There's a lot of literature about the subject. It's really important to sort of look at diverse methods, but do not look for the magic solution. Look for methods that resonate with you, that fit your context, and take elements of them to combine them. But remember, as I said at the beginning, your mileage will vary. So I just want to say there's a lot of approaches. I'm going to show you just one here. Estimates are moving targets. Projects are moving targets. Things are dynamic, not static. So it's an important thing to re-estimate. So it's an important thing to re-estimate. Some people make the mistake in Agile projects of sizing a story and then 3 months later still using the same size or using the same estimate. Things will change. You should estimate things closer to when you implement them to get more accurate estimates. And in large projects, you should periodically re-estimate. So re-estimation becomes a process. It's not just a thing you do once. It evolves. And eventually, with time, it converges. Estimates converge on reality. There's something called the cone of uncertainty, published by Steve McConnell in his book, Software Estimation, which is awesome, has so many different estimation techniques in it. And in it, he describes the cone of uncertainty. Actually, it's Barry Boehm who first published it. And it shows that as you get further along, your estimates start converging. And there's a point where you get where it follows like a, how can I put, like a sort of a shape that's like a decaying exponential. However, it gets, as you get closer to the project's termination, your estimates get better and better. Obviously, the day before you're finished, you know exactly how much time it's going to take. But earlier on, you can be really off. And so if you re-estimate, then the estimates get more and more accurate. After my experience is 2 or 3 re-estimates, spaced maybe a week or 2 apart, suddenly you're going to start seeing it's converging, and you're starting getting a better idea of what the work's required, and you're giving your stakeholders a better idea of what the trade-offs that have to be made to do good work are. So estimates converge because you force people to make good decisions, and they change the project, and you sort of converge on something meaningful. Anyhow, this is the reality of estimation. It's a moving target. I believe in a lot of different approaches, but the approach that I think is most beneficial for me is a work breakdown approach. So I like to break a testing project down into elements of work, and I want to estimate those elements of work. So that's why I call this a simple, effective, experience-based test estimation. And it's basically looking at the work that's being done. And I basically start by saying, okay, in testing, my experience says I want to learn things. So for me, testing is almost always about learning. I want to learn about things. And so I have a list of what do I want to learn? And the list of what I want to learn are my test objectives. What do I want to learn? I want to learn about performance. I want to learn about functionality. I want to learn about, and I have a very specific list of functionality. I like to break that down to a granularity of tasks. This is very commonly done in project management, but it's also commonly done in Agile teams, where you basically create a task list for every story. You have a list of tasks, and a task is the work done by a person. So it's not a magic thing. It's a chunk of work that can be done by a person. And my favorite way to describe this in testing is using charters. So a charter in testing for me is a mission statement for a testing objective or part of a testing objective. What do you want to learn about? Now, just to share with you an example of what that is, and this, of course, I'll include it with any files I share at the end of this session, but just to go to my documents here, just a second. I have a list here. So this is just a simple thing called some testing tasks. So when I have a project and I want to do this task-oriented estimation here, I break down testing work into a bunch of tasks, and I make a list of them. And there's some tasks are about different things. So this is just a checklist for me on types of tasks. Some tasks are about infrastructure, setting up tools, frameworks. Some tasks are data. In fact, in many companies, 80% of the work is related to data, and 0% of the estimation, it considers data. So big data. How do you create data, generate data, validate data, model data, script data, data. Then there's customer-facing tasks, right? Running your story test, doing cross-functional tests, testing with customer data, pairwise combination testing. Those are customer-facing. Then there's non-functional testing, all the abilities, reliability, scalability, all this type of stuff. There's tons and tons of non-functional testing. Those are possible tested tasks. There's robustness testing. Sometimes we actually care that the software is robust. Is it flaky? Is it solid? Does it crash all the time? Does it corrupt data? So there's robustness tasks. There's exploratory testing tasks, things you want to do exploratory testing on, capabilities, creative items, cross-story relationships, end-to-end tests, experience-based tests, gaps in tests, all of these type of things. There's tasks related to regression, right? Automating regression testing, designing regression tests, doing unit tests, all this type of stuff. And there's development-facing activities and business rule activities, etc. This is just for me to help people think of breaking testing down into tasks that can be done by people. So that's a very important part of estimation for me. Break it down into work that can be done by people. So for me, that's an important thing, work done by a person. What's the granularity of work? My habit is to break it down into activities that are generally between 1 hour and 2 days, if it works okay. So it might take a lot longer if it's full of bugs, but if it worked okay to do this activity would take me between 1 hour and 2 days, somewhere in that range. That's the granularity I like to shoot for. Even on huge projects, I'm able to do that because I understand the test objective. I can make a list of the activities and I can basically shoot for that granularity. Of course, I'm going to be wrong, but with more knowledge of past experience, you get really good at it. And with time, you'll get better. It's never going to be perfect, but you have a list of activities at that granularity approximately. So if you think that you've got a testing activity there and it would take someone 3 weeks to do about that granularity, that's for me way too big for my estimation. I want to break that down, break it into smaller chunks. I just spent yesterday a couple of hours looking at this very issue with a customer of mine, believe it or not, in Colombia. And they were talking about software for one of the most important travel sites in the world. And their granularity for every single task is between 1 hour and 8 hours. As a rule, they never break it down bigger than 8 hours. And that's huge company, major projects all over the place. So it's not just Rob saying this. It's really important. Break it down to chunks of that granularity. So that's just work breakdown. Important part here. I believe in three-point estimation approaches, and I use the PERT equation a lot. If you're not familiar with the PERT equation basically says once you've got an activity, if you want to estimate a task, what you should do to try to come up with it is to look at that task and look at your experience on it and say, okay, well, what's the typical effort for a task like that based on your past experience? So you have that number, the typical number. But then you have, well, if things really go bad, what's the pessimistic number? What's the worst case? And that's not infinity. It's a real number because you're practical. And you know that if this activity takes you more than 2 days, it's ridiculous. You're going to stop and do something else. So there's a pessimistic value. And then there's an optimistic value. If everything is perfect and everything goes well and you get it exactly what you need and the requirements are right and it's all clean, there's an optimistic value too. So you take the optimistic plus the pessimistic plus 4 times the typical and divide it by 6, and that becomes your PERT estimate. This is the PERT estimation approach. You can look it up. There's books. The PMI, Project Management Institute, advocates this type of method or the family of method. Steve McConnell describes it nicely in his book, Software Estimation. And there's even, I believe, a Wikipedia page on this. Anyhow, this is just, for me, a 3-point estimation thing to keep in mind. I'm always using this. So I always look for 3 numbers. What's the pessimistic, what's the optimistic, and what's the typical? 3 numbers, not just 1, right? 3. Okay, and I also like to use team-based approaches. If you're familiar with planning poker from Agile, there's teams. I don't like to do this in isolation, but usually people ask me, how can you get someone who doesn't understand testing to help you to estimate better? And the answer is usually they can help you identify missing testing objectives. So they can't really help you with the details of the numbers, but they can help you with the list of things that are interesting to learn about. So this team-based approaches are really helpful for that, even people who are not testers. So let me show you how I like to implement SEBTE, simple, effective, experience-based test estimation. I start with the hardest problem. How do I collect data? How do I collect data? Well, basically what I try to do is whenever a testing task is done, I try to collect the actual effort required to do the task. So if I was a Scrum Master in a Scrum team, if a person said the task is completed, I would just ask them the question, how much effort was required to complete that task? At that time, I would collect that data. It would take, for me, a few seconds per task to collect that data during a normal stand-up meeting at the beginning of every day in Scrum. That's what you do. If I was using Jira and I had a task in Jira, when the task is closed, I would put a field in there. I would make sure there was a field where the person who closes the task puts in the effort they did the task on. So I collect it when the task is done. This is how I collect that data. So I have the task, and when it's done, I collect the data about the task. And I like to do that. I have, as I said, in one of my customers, over 10 years of data like that. It's not hard to do. It's a natural. I've learned that collecting data, if it takes more than a few seconds per task, people will not do it. If it requires bureaucracy, if it requires fancy tools, people will not do it. It's got to be simple and a natural part of your day-by-day work. I'm lucky in Canada, we have something called income tax credits for research and development. So people on software projects always have timesheets. And so I've used that for years to collect data. It's mandatory here for us to get tax credits, so everybody does it. So it's part of the culture of our country to collect that data. But whatever it is on your team, find a mechanism to collect the data. This estimation, almost any estimation method will be very ineffective unless you base it on some sort of past data. And I'll show you how I do it in my spreadsheet example. Second thing is the data has to be related to the same team of people. Maybe you can have slight variance, but if the team changes dramatically, this method I'm going to show you is ineffective. So you need to basically consider this method is for the same team. If the team changes, the method will continue working, but you have to recalibrate it. You have to reset it because it's based on the skills and experience of the team. The team changes, the skills and experience changes. Therefore, the amount of effort required to test it, a tester with different skills will test things faster, slower, find different types of bugs, have different depths. There's all sorts of elements of it. So when the team changes, I recalibrate my estimates. So be careful about that. Don't think this is magical. It's based on the team, the effort estimate of a team, a group of people who collaborate together to get the job done. After each task, so I capture data. And the data I capture, some of it I've put together before and some afterwards. So for example, when I'm in a planning meeting, like an Agile planning meeting at the beginning of a sprint, and I discuss the testing work to be done for a story. So we look at what's the programming work, what's the testing work, we break it down to tasks. For every task, I want to assign at that time two numbers to it, two values. One is a size and one is a complexity. So the size has to do with how big it is. Very often it's about how many factors we have to consider. And the complexity is about the nature of what's changed. So the complexity is related, if you will, to risk. What has changed? What has technically changed? Has the environment changed? Has the code changed? What and how much changes there been in or related to directly or indirectly the test objective. So for every task, I have a size and complexity, and I'll show you what it looks like in the spreadsheet. And at the end of the task, I collect the actual effort. So for every task, so for one story, you might have 20 testing tasks, for example. So you collect 20 data points for every story. And if a sprint has 5 stories, that means you've collected over 100 data points for every sprint. After 10 sprints, you've got 1,000 data points. You start getting incredible collections of past data, which can help you do amazingly good estimates. So the data is there, and it's trivial to collect. It is not hard to collect. Let me show you how I do it. In this example, sanitize to protect the innocent is in an Excel spreadsheet. All right. There's a couple of ways to do it, but the beginning, I start here on the left. So you'll see that every time a task is finished, you just add a row to this list. So you see this list, it's got 3 columns. It's got size, complexity, effort. Size, complexity, effort. And basically the size is small, medium, or large, right? Small, medium, or large. And the complexity is simple, typical, or complex. So those are the 2 dimensions. When a task is finished, I collect the effort and I write down what was the size and complexity based on our planning meeting. Not at the end, at the beginning. What did I think the size and complexity was, and what was the actual effort? That's what I'm collecting. So the size complexity, it's when you add the task, when you put it into JIRA, when you're in that planning meeting and you identify it, you just tag it, you say, what's the size and complexity of this? It's not rocket science. The team knows, the members of the team will be able to ascribe that because you've come up with simple definitions and you have past relevant examples that you can look at. So if I look at the definitions, just for example, a simple definition of simple, right? Here we go. So for size, small means few variables, less than 5 variables, less than 5 factors we're going to consider for this test objective. That's small in this case. A medium would be a nominal number of variables, something between 5 and 10. Variations between 5 and 10, by the way, makes suddenly the testing get really, really challenging, but that we call it medium complexity. Then a large complexity one is when you have more than 10 factors to consider. So that's an example of one way you can size something. You size it in a way that makes sense for your team. And I like to use 3 levels, but you can use, I've seen up to 5 used effectively, up to 5 used effectively, but 3 is my sort of preference after years and years of doing this. And I like your team to come up with this. Don't listen to me. Come up with your own view of what is size. But size is nothing to do with complexity. Size has got to do with factors. How many factors do we have to care about? Complexity is about risk. So in this example, we break it to 3, simple, typical, complex. Now remember, I'm not using small, medium, large again. I'm not using 1, 2, 3. I'm using words that are different. For size and complexity, different terminology, because I don't want people to conflate the concepts. So simple might be no changes to the logic. So in place code changes, data changes, no change to the logic. Typical might be there's some changes to the logic, some changes to the schema. Complex means it's new, it's refactored. It's stuff we never had before. So that's an example way to have a size and complexity. So for every task, when you identify it, you ascribe a size and complexity. And when you complete it, you capture the effort. In this example, the effort unit I'm using is the session of testing. So we're doing sessions of testing here. A session of testing is considered to be about, in this case, 90 minutes of testing uninterrupted. So that means you turn off Facebook, FaceTime, Twitter, everything. Don't shut off the phone. Don't let anyone interrupt you. Focus on your testing for 90 minutes on one specific objective. That's a session. And what I'm capturing is how many sessions did it take to do this charter? How many test sessions did it take to do this activity? And that's what we capture at the end. So it's easier than saying how many minutes or hours. For me, sessions is the beautiful unit to use for this, but use whatever unit your company wants. Again, it doesn't change the method. Now you'll notice that I've collected in this example here, there's about 70 something rows here, or 50 or 60 examples. This could grow several hundreds very quickly. And this table on the right then is your estimation table. So what you do here is now is in the planning meeting, when you say, hey, I have a task of, let's say, small, simple, well, the estimate for that would be 1.7 sessions. If it was medium simple, it would be 3 sessions. If it was large complex, it would be 8.8 sessions. And that is the estimate that I would use so that during the planning meeting, we know, hey, we have 3 weeks to test, or we have 3 weeks of work, and the amount of effort we're going to have is this much. If we add the tasks together, we can say, does that fit or not in the sprint? And then we can discuss which tasks should we do, which tasks shouldn't we do, which should we scope, which should we not. We can have that discussion so that we come up with an acid balance of testing that reasonably fits within the sprint. And after a few sprints, you get better and better. The data gets better and better. And this just gives you wonderful, wonderful results with time. The calculation comes from looking up data in the table. The worksheet functions are here, and the estimate is using the PERT equation, exactly as I described. So it takes basically the minimum plus the maximum plus 4 times the typical. The typical is not the average, it's the most common. It's numbers of sessions, it's a whole number. What's the most common whole number? So it's the mode, it's not the average. If you're not familiar with the difference between mode and average, you should learn that before you get into estimation. It makes a big difference. And this is it. That's the basic SEBTE approach. Back to my mind map. If I can find it again here, just a second. All right, so I told you the units. I like to use our sessions, but you can use whatever units you want, person hours, etc. It's estimate based on past data. It's trivial to collect, easy to use, and because it's trivial to collect and easy to use, I've found it sticks. So methods like this stick, but it's not everything for everybody. This method does not include capital costs. This method does not include depreciation. This method does not include fixed costs. This method does not include learning curves or training activities. So it does not include that. It does not matter. Also, this method doesn't care if you automate or not, whatever, it doesn't care. As long as you break it down into tasks in the granularity we're talking about, in my experience, between an hour and 2 days, that's what you're shooting for. You may not get it, but you shoot for that. Then whether it's automated or not doesn't matter. That doesn't matter. And with time, you'll see that that just builds into the collection of information you're putting together. So that concludes my quick introduction to a simple, effective, experience-based test estimation approach. So I'm ready to take questions or discuss things, whatever the natural next step is in this webinar.
Thank you for this, Robert. It's been fascinating. We actually have some questions waiting from the chat and the Q&A. So we'll first ask if you can explain session, please, again. That was from the last slide that you referred to.
The question is explain sessions?
Yes, when you referred...
First of all, there's a type of testing that's been popularized since the late 1990s called session-based testing. So session-based testing is a way to organize testing. And what you do is you give work to a tester, you give them a task or a chunk, any way you break up the work, I don't care how you break up the work, you give it to them, and you give them like a charter, a statement of what the work is, and then you ask them to test, and they test chunks of time, which are called sessions. Sessions are time boxed, just like a sprint is time boxed in Scrum, a session is time boxed. Typical sessions are 90 minutes to 2 hours. However, some companies use short ones, 45 minutes or smaller. Some companies use longer ones. If you're doing non-functional testing, it might make sense for a session to be even several days long. But it's an uninterrupted amount of time that a tester will focus on one charter, on one very specific task. So that's session-based test management. And I'm a huge advocate. I love doing that. I have a book I wrote on the subject. I'm happy to share with anybody who's taken this webinar. I'll give you an electronic PDF copy of it. But the method is basically a work breakdown, that's all. So it's the way you give the work to someone who's a tester in your team. So you break it down into objectives, charters, and chunks of work, and you give a chunk of work to someone, and then every session, they pause. They do the work up to the session. They're not trying to squeeze it into one session. Instead, every session, they stop, they review what they did, they accrue value in your project, they share what they learned, you take action on it, and you decide, is it worth continuing to do another session on this charter, or should we move on to something else? Sometimes it makes sense to stop after one session. Sometimes it makes sense to continue for 2 or 3 sessions. But the session is the unit of time where you stop and you accrue value, you report your bugs, you share what you've learned with your team, and you try to decide, should I continue or did I learn enough? Because testing is open-ended. Edgar Dijkstra in the 1960s showed this very clearly in his publications. And to quote him, he said, testing can demonstrate the presence of bugs, but it cannot demonstrate the absence of bugs. Effectively, testing is intractable. Even the simplest testing activity can go on forever. So in order to avoid that, I use sessions. I go for a session. I look, what did I learn in that session? Should I do more, or did I learn enough? And I force myself, I really set up the team so that when a tester finishes a session, they pause, they try to add value, they report their bugs, they share what they've learned, and they decide with their stakeholders, should I move on, or did I do enough? So that's from session-based test management. The earliest publications were by John Bach, based on work at Hewlett-Packard in Front Royal, Virginia, in the United States of America, and I collaborated with him for years on this method. Next question.
The next two, perhaps I'll combine two of them, because you presented the Excel, the spreadsheet, and then there is a question of how do you recalibrate the spreadsheet with changes in team. So this is one. And the other one, which I connect, if I may, is in scenarios when user Jeff asks, when you have scope, project that are scope up front, okay, with testing estimated backed to the work. So how do you advise to manage those? So essentially, how do you take, I think in both questions, so how do you adjust this to changing scenarios, either in personnel or?
So the new personnel thing is unfortunately, I basically will start collecting new data again. So I'm going to use the old data for 2 or 3 sprints as a heuristic, because I'm going to say it's going to be a good guess, but I start collecting new data from scratch. Any major change of the team, if it's Scrum, it'll be when the team starts. So if your team changes every sprint, SEBTE won't work for you. I'm sorry. If you're changing teams, if it's different teams all the time, this method won't help you. And sorry, this method really depends on the teams. And frankly, I've worked with testers, even experienced testers with lots of experience, and they dramatically have different ways to test, different choices. And it's so different that it does affect the estimation. And so the estimation approach really demands that if you have a team change, that you recalibrate by just restarting to collect data. And while I do that, I like to keep, as I said, about 3 sprints. I will use the old data, so it's still useful, don't throw it out, but I'm going to start collecting new data right away with the new team. So that's the recalibration. The other point is what the scoping issues on projects. So task-oriented things, if you change the scope, you're going to change the tasks. So you have to go and you really have to redo the work breakdown. And that's the reality of it. However, if it's before the project starts, you can use zero information methods, as I mentioned. But if you're in progress and the scope is changing in the middle, you really got to say, okay, that means my list of activities have changed. And some of the list of activities are similar to what they were before, some are not. But what's interesting is you got to force a discussion about what's in scope. Like if someone is changing the scope and they're saying you got a fixed delivery date, that forces a discussion of what are we not going to test? And we have to deliberately decide what not to test. We're not going to skip things because we ran out of time. We're going to skip things because business is willing to take a risk in that area. So I really believe that we have to force the discussion of the scope and depth of testing, and always have different depths you can do. Always have a way to test something very shallow. Like I'm just going to demonstrate that a typical transaction works with typical data, but I'm not going to check any edge conditions, and I'm not going to check any memory things, and I'm not going to check any stress. That's very shallow testing. And very deep testing is harsh, has a lot of variations, there's a lot of different things going on at the same time. And you can make that discussion with your stakeholders, turn it into a discussion of risk. I don't know if I'm answering the question correctly or succinctly, but there's definitely a dialogue. And once I've got that list of tasks, though, then my estimation is still going to be handy. I'm still going to be able to estimate the work required to do the task. But the discussion of what tasks are in and out, for me, that's with the stakeholders. And that is a beautiful discussion, and it should be very fluid. If they come to me and they say, hey, the project has changed, I'll say, great, yay, we're going to make more business, we're going to make more money, but we have to change the scope and depth of what we test. And we have to do it in a language that our stakeholders understand.
Good. So first of all, yes, Jeff answered that you did answer his question. So good for that. And another one was a question about.
Any next question? Should I go to the next one in the?
It's just one above that I skipped, if I may go back, is how do you count the preparation of test data?
I don't
Question
see
by Robert.
Okay. I got some of it. Again, have a nice day. I see that.
Oh, hold on, I'm going to show it. I'm going to ask again. So Robert asked, how do you count the preparation of test data?
Oh, very easy. That's just an activity. That's an activity. That's a task. It's got a size and complexity. So if I have, for example, a type of transaction and I have to prepare test data, you identify the task is prepare test data for this type of transaction, and you basically say, okay, what is that? And usually you look at a granularity thing. If it's something that you think might is huge, you might break it down a little more. But generally, what I'll do is I will identify that as a testing task, and I will give it a size and complexity. And usually the data ones have low complexity, but high size, unless you're in medical information, for example, where the data, you have to use analysis methods to get the data. But if it's just constructing data and assembling it in the right form, what I like to do is basically just identify that as a task or a series of tasks, and each task assign it a size and complexity. Usually the data ones have high size, low complexity, but I still identify them explicitly. And that's part of the discussion in the planning meeting. Have that discussion, because actually some programming design alternatives will require dramatically different data preparation activities. And I see testing teams, as I say, with 80% of their effort is on data collection, preparation, management, validation. And they don't even include that in their estimates. Like, of course you should estimate it. Identify tasks related to it on a story-by-story basis. That's how I like to do it.
Thank you. I think we're good with questions. And I'm gonna quote Jeff, who just apologized that he had to leave because I couldn't agree more. This was an excellent session. Thank you, Robert, so much. I hope everyone in the audience enjoyed it as much as I, myself, and Jeff did. I've learned a lot. I think it made a lot of clarity into stuff that we know a lot in many cases, but are not well enough organized. So that was very well structured and helpful. Thank you so much.
Awesome.
We will share, I see another request for the documentation. People ask for it frequently because it was very, very helpful. So we will share it. Thank you so much, Robert, for allowing us to do so. With everyone.
Let me know. I'll send the link to you guys, and you make sure that the participants.
Yeah, absolutely. We will collect it from you, and then we will share it with everyone who signed up. Thank you, everyone. Have a good rest of the day. Robert, it was a pleasure once again.
It's an honor to be here, and I'm happy to come back again. And please, please, please continue to ask me questions. Send me an email. Just as long as you remind me where we met, I'll be delighted to guide you, help you, give you ideas, point you to references, give you examples. It's
absolutely
a pleasure. Thank you,
Robert. One last thing, I see that people are asking for links for your books, so I will ask for them in emails as well, if you will be willing. That you've mentioned.
Everything I mentioned, I'll share it with you in one Dropbox link.
Perfect. So we will spread around.
The spreadsheets will be there. The mind map will be there.
Wonderful. Thank you so much, everyone. Have a great rest of the day.
Thank you, everybody. Good to have you.